Welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. In this video, we're going to continue our example from last time. We were looking at how we can think about problems in an object-oriented manner and how that changes the approach that we have to them. We decided to do this by writing a little game, and we had gotten to the point where we could run the game and we could place these little bombs around. Oh, hey, actually I have it now so that they do explode, at least in that compiled version. Where we had stopped last time was nothing happened that was active. And for that we needed a timer. And so to go back over what we have here in the code, we start off with some declarations of variables in this main object for the enemies that we have, the bombs that we have, and a time counter that's keeping track of what times that things are, so that when we do things like add bombs, we can deal with that. We have a panel that blanks out the middle. Let's go ahead and add a space there. It draws the enemies that we have, draws the player, and draws the bombs. And the thing that was really different about this is that the way this is written, it doesn't know, the code that goes here does not know how to draw enemies or bombs. The code for the player is pretty much hard set in there, but this other code isn't. Right now we have it set in color, though I have to admit there's a part of me that kind of wants to even pull back from that, and maybe we will later on and put the color settings inside of the enemies. Actually, forget later on. Let's do that now. G.set paint to color.blue. And of course this requires importing also color. And we'll need to do the same thing here. The reason for doing this here is that it actually, the thing that at least I had been thinking about is, right now there is no graphical indication that a bomb is about to go off, and it might be interesting to have it scale from black to red as the delay changes. But I'm not going to put that code in here yet. But by doing it this way, we can do that without the main part of the program actually knowing anything about delays, because we might want to change how we do delays later on. And if we put the code for changing colors based upon delays out in that main method, we're really limited in the flexibility that we have inside of the bomb. And so if we come back here, let's make sure that I didn't break anything and this still compiles. Okay. So if you look at this, the real big difference here is that we're telling the enemies to draw themselves, and we're telling the bombs to draw themselves. And that is much more of an object-oriented approach to it. We didn't write some function inside of here that does the drawing and then we call it. We put that off in the class that represents these other objects, so that all the code that's associated with them is localized. Then we put in some variables and some event handling so that we can place the bombs. We make a frame and we open up the frame inside of the main. Right now that's all that happens in the main. And what we have to add to this is some interactivity. So here, let me go ahead and run this so you can see. And yeah, so there's the bombs, there's that. Everything still works in much the way that it had been before. We need a timer. So we're going to make a new javax.swing.timer. Could go up and import that, but we're only going to use it in this one place. I'm going to give it a 100 millisecond delay so that the timer ticks 10 times a second. We can come back and think about that, but for the timer that's probably a roughly a good number. We could go up to 20 times a second if we wanted to, but that's kind of the range that we want to stay in. And then I'm supposed to pass this an action listener. Now the action listener is part of the Java libraries, but you might recall that there is a helper object inside of the Scala swing library is called swing that we can use to make an action listener. We pass it in the event, and in our case, we don't really care what that event is. And I'm just going to put inside of here a game panel dot repaint. That'll also mean that now when we technically we wouldn't have to do this on the mouse release, because 10 times a second the panel will be redrawing anyway. So what else should happen here? Now that is actually the code that makes it so that, whoops, not quite. I left out one line. You can see that. I was going to say now the bombs will actually explode, but there's one thing that's missing here, and that is the fact that I have a timer, but if I put a print statement in here, nothing would be happening, and that is because I haven't started the timer. So after I open the frame, I will start the timer. Now if we recompile, we run, that is how we get there's something interesting going on there where I hold down I was holding down the mouse button and releasing it significantly later, and it wasn't doing what I wanted. That requires us to put in some print statements. I have a fear of what that might be going on here. Recompile. Run. Press down, hold, release, short click, short click. Oh, I know why. In fact, those zeros make it very clear. Hopefully you can look at that and realize why too. Somehow time's not counting up. Well, we created time at 0, but there's at least one other thing that needs to happen inside of this timer down here. We not only need to repaint, we need to increment time. So we recompile. We rerun. Click 1, 2, 3. You can already see that we have a benefit here because that was and so you can see that the size of our bombs is changing based upon how big things are. Okay. Now, what else needs to happen in the timer? There's a number of things that need to happen. We need to make it so that the enemies are placed at random time intervals. So let's see. So place new enemies. Remove exploded enemies. Is there anything else that should happen inside of? Oh yes, move the enemies. Okay. So placing enemies. This should happen at random intervals. There are lots of ways that we could write this. Right now the timer's happening 10 times a second, which means that if I want a new enemy to appear, say, every, I don't know, let's go with an enemy appearing once every 5 seconds or something. One way to do that would be to say if math.random is less than 0.02. So 0.1 would be about 1 appearing every single second. 0.02 would be 1 appearing, so 0.2 would be 2 appearing every second, and this should be 2 appearing every 10 seconds, so 1 appearing every 5 seconds. But it's going to happen randomly. It's not going to be at fixed intervals. So what should we do here? Well, what I want to do is add something onto the enemies list, and I want to add a new enemy. And when we build an enemy, we have to give it an X and a Y location. So at least to start off with, just so that we can see how this works, we could put it at 0, 0. That way we should be able to immediately see it, and if it moves, it should go where it's supposed to. For the moving, how about that? Once again, just like with the drawing, I want to make it so that the enemy knows how to move itself. And maybe later we'd have to give it some additional information. Right now the player is always, actually let's go ahead and do that. And I want to have it so that it kind of knows where the player is, where it's moving towards. And we have those values right up in here. So I'm going to do something in this and make some variables because I don't want to have to type that. Paste again. Second one is the Y. Oh, except I need these to be, if I make them vowels, nope, I will, this is an interesting, how about their defs? And since I bothered to type those there, I don't want to have them repeated up here. Now, you might be wondering, okay, what the heck is he doing? Why is he talking to himself? What are we going through here? Yeah, I don't want this to span 5 videos, so I'm actually looking ahead a little bit. If I were to make, so first off, this expression uses the size.width. Well, that only exists inside of the panel, so I can't put it up here. Second of all, if I use a val instead of a def, it's only going to be evaluated once, and it turns out that when I make the, if I were to resize the window, it's one possibility, or if we were to, I don't know, let's say, if I were to, so when you resize the window, or turns out if it's a val, it's going to be evaluated right at the beginning. Well, it'll probably be evaluated at the beginning before the frame is even open. And if you ask a panel how big it is before it's being displayed upon the screen, you don't get the answer that you want. It's generally not going to be how big it's going to be. Generally, you get a size of 0 out of it. And so that would have been unpleasant for us here. So I put these into here. Oh, am I going to be able to, actually, let's even pull these out one more level, because I do feel like I'm going to need them to be out here. But now, okay. Just to see if that code is still happy. See if the scoping is in there. Oops. Line 21. Not certain that I agree with there. Oh, it's because of the location of definitions. Okay, now we're down to the fact that our enemy doesn't have a move in it. But when I tell the enemy to move, I can pass it these two variables so that it knows where it's supposed to be moving to. And so we can go inside of enemy.scala and we can write a move. The end location in X and the end location in Y are both doubles. And what I'm going to do here is I'm going to change the values of the X and Y based upon those by a certain amount. How about we do this? Val equals EX minus X. Val dy equals, actually I want the x minus ex, y minus ey. This is basically the distance from your current location to the end. And if it's oriented from your current location to the end location, and what I want to do is since we're doing these as doubles, I have the ability to make it so it moves fractional distances. So what I'm going to do is alter this. I'm going to make it so that it takes a step 1 unit long in the direction towards the destination. Let's try compiling. See if we have that all typed in correctly. Getting clicks. I'm not seeing any enemies popping up in here though and being drawn out in red. Because we did say that we wanted to have that. So let's go back and look at our other code and see what is wrong with the creation of new enemies. Making an enemy. We know that it is getting here because it is doing the time increments and such. We can actually get rid of these print lines. They were sufficient to help us fix our problem. And now it's worth seeing if we have enemies. Or more importantly, do we have that print statement? I'd actually be very surprised if we see something different in regards to enemies. Oh, made an enemy. Should do, once again, 1 every roughly 5 seconds. And so then the question is, why is the enemy not drawing out? Did we edit? Okay, so when it calls draw, it sets the color to blue, and it draws them at that location. If your X is at 0 and the player is big, this is a negative value. Oh, apparently I have it so that we're moving away. I do want this to be, oops, that. So if the end is at 200 and you're at 0, then this is going in the positive direction. Okay. I'll describe this once I have the window up, because it's going to be hard to explain otherwise. When it prints making an enemy, we should see a little blue dot start there and start moving towards us. what was happening was because of the sign, the enemy was starting there and then it was moving away immediately. So it wasn't exactly very visible in doing that. Okay, so making the enemy start at random locations would be a nice addition. I'm not going to write that right now. I'm also not going to write the part where the enemies actually kill the player. I'll leave that kind of as an exercise for the viewer. There is one more thing I would like to write in here, though, and that is to make it so that bombs can kill enemies. And remove exploded enemies. Also, oh, that's right. Remove spent bombs. Okay. Once again, I'm going to approach these with a top-down style. I want to bombs equals bombs dot filter not underscore dot spent. Okay. So a spent bomb is one that has exploded and gone for at least a short delay. So bombs shouldn't stay there forever when you set them off. There's only a certain period of time when they're able to kill enemies. So I need to add a method called spent into the bombs so that the bomb can tell you whether or not it should still be there. And once they are spent, they should disappear. What about this one? This one is a little bit more interesting. It should do a similar thing where it should say enemies equals blank. Okay, some new set of enemies. How can we do this? There are a number of ways that we could play with this. So enemies.filter, we're either going to use a filter or a filter not. This is who I want to keep. Okay, who do I want to keep in here? I want to keep the enemies that are not intersecting with any exploded bomb. Okay, and perhaps the ideal way to do this is to underscore dot. Let's do a filter not. I'm going to write a method called killed. So I'm going to pass each enemy in turn all of the bombs, and I'm asking the enemy whether it's been killed by those bombs. Let's go ahead and let's open up. First we'll do the bomb, and we'll add the spent method. Def spent is going to give us back a Boolean. And I want this to be spent in the situation where, so it's going to return detonated and delay. You know what? Now that I think about it, I actually don't need a detonated in here, do I? If I just let the delay keep counting negative. So if delay is less than 1, then I do this. It is spent in the case where delay is less than -5. So once you get down to 1, it detonates. Once you get below -5, it should disappear, is what that is implying. Now what about in our enemies? Well, we need another method added in here. Def killed by bombs is a list of bomb. And this is also going to return a Boolean. And so when are you killed by a bomb? Well, I would argue that this is you've been killed by them if any of the bombs overlap with you and they are detonated. Now that's a bit of a challenge because in here in the enemy, we don't know if the bomb's been detonated. That's data that's hidden away inside of the bomb. We also don't know where the bombs are. However, what we could do, so you've been killed if there is a bomb that for which it exists that the underscore dot hits our location. And now I'm just going to go with our location. I'm not going to add the size of the enemy. The enemy has to be like have its center inside of the blast radius, if you will. And so this requires now another method to be put inside the bomb. A def hits. And this needs to take an X and a Y position for, actually that would call it just PX. Who knows, later on it might not be an enemy, it might be something else that we care about here. Hits is that, returns to us a Boolean. So there are some aspects to this. First off, you can only be hit if it is detonated. So if delay is less than 1. And what else? You also have to be within a certain distance. So this comes back to our distance calculation of dx is equal to x minus px, val dy is equal to y minus py, val the distance between you is math dot square root of dx times dx plus dy times dy. And then what we want to return here is distance is less than or equal to size. Note I'm using the curly braces here. I could have put this inside of some type of a nested if, but I'm perfectly happy just using an and here and making this all just one kind of longer expression. Let's see if we typed in everything correctly there. There's just enough code scattered around that it's quite possible that something went awry. Apparently that was happy. Click, hold, 2, 3. Notice an enemy went away. Click, hold, 2, 3. Oh, I was a little bit later on this one, but okay. We can take out the print for making an enemy. So we have basically here what is kind of a functional game. This would obviously be much harder if the enemies were coming from all over the place. That is what it's supposed to do. Because you have a limited time window on these, you can do things with small blasts, but you just have to time it right. Oh, because that one I missed. I held that one a little bit longer, so I have some more margin for error. But that sets up the basics of the game. I will, as I said, leave it as an exercise to the student to put in anything else that you want on top of this code. Things such as the random location here, probably somewhere in the timer have a check on whether an enemy has hit a player, maybe give it so the enemy has a certain number of lives, or so, not the enemy, the player has a certain number of lives, etc., etc. You might also want to make it so that bombs can't be placed and can't hit the player, and you could take out your own lives, stuff like that. So there are lots of ways to extend this, but hopefully this has given you kind of a feel for how you want to think about stuff in the object-oriented way, how you think about putting methods inside of objects, and how that winds up controlling things. So that's it for this video, and hopefully we'll see you again soon.